Hello and welcome to another episode of Momento Malum today. The common lentil is a self-pollinating diploid legume species. This species is one of the main domesticated crops of the Near East. It is from this region that lentils spread across the world, going from the Near East to Europe and Central Asia, and from there, the rest of this big old planet of ours. In modern times, lentils are grown across the world, and the world production of lentils is currently estimated to be 4.4 million metric tons from an estimated 4.2 million hectares. The government of Australia has acquired various samples of various lentil landraces from across the world, all of which are now preserved in the Australian Grains Gene Bank. Many of these landraces were collected, but not used in breeding programs. Many of the key improvements in yield and disease resistance are the result of the broadening of the cultivar gene pool through the gradual incorporation of landraces into the gene pool. One primary goal within this project and organization is the conservation of landraces to assess, maintain, and catalog the available genetic variation within and between landraces for breeding programs. Genetic diversity between parental genotypes in crossbreeding programs has been demonstrated to be important for effective cultivar improvement. To determine the genetic diversity of the current gene pool of lentils, 505 genetic lines were analyzed by Australian researchers using the SNP genetic marker technology. These include 111 commercial cultivars and 394 landraces. The goal was to determine the full gene pool of the existing lines within Australia. This was done by Dr. Lombardi of Australia, and here are the results. If you want to donate to my channel, the links are below. If you want to buy my book, you can also find that link in the description box below. Based on the genetic data, the commercial cultivars and landraces separate into two groups: the commercial cultivar group and the landrace group. The commercial cluster splinters into 3 clusters that are closely related. Cluster 1 consists of the majority of the Canadian and United States cultivars. The third cluster consists of the remaining Australian cultivars. The landrace group splinters into groups based on geographic locations. These would be the American, Mediterranean, African, Northern European, Eastern, and Asian landraces. The Mediterranean landraces primarily stem from Turkish and Greek genetics, but the genetics of others were too genetically narrow to tease out any further, so the researchers could not draw any more conclusions from this data regarding the clustering of these other landraces. The overall genetic diversity of the lentil landraces seemed to be lower than the pea, soybean, and alfalfa landraces. The genetic analysis also found that there was poor record keeping in the previous Australian breeding programs, a similar phenomenon found in many other breeding programs. Many of the cultivars' stated pedigree is at least partially false, based on its data. Even still, the landraces still have a greater level of genetic diversity than the commercial cultivars, and are recommended to be used in further breeding programs. I would speculate that the Greek and Turkish landraces may have the widest array of genetic diversity amongst them, as the rest of the landraces are genetically close, indicating a major genetic bottleneck. But that is just my speculation. And that will covers everything. Thank you for watching.